Hey guys, Space Marine 658 here, and I am here to bring you another tutorial. Today we're going to be actually delving into C++. This is something I've been diving into a little bit more recently of late in Unreal Engine. I have a background in coding. My courses were digital media, so it was half coding, half art. But what I want to kind of go over is sort of Unreal Engine's implementation of C++. In using that to create a missile. Specifically, this is just creating the actual missile itself. From there, you can create a launcher to launch this missile actor. But specifically, we're going to cover the actual missile, how to make it rotate at a target, how to make it do certain things with Niagara, that sort of thing. So, with that, we're going to kind of start at the basics. So I've gone ahead and set things up so it'll be a little easier to understand. Now, this is not meant for complete beginners to Unreal Engine C++. If you're a complete new beginner, there's some really great tutorials out there for just setting up your dependencies, getting it running in Visual Studios or whatever IDE you want to use. A lot of people recommend Writer and all that. So if you want to do that, I definitely go check some of those tutorials out. This is more for those people who've created some stuff in Unreal Engine C++, but aren't maybe know all the little ins and outs. I'm going to try and give you more of a peek behind the curtain when it comes to looking at, creating, for example, rotational functions. Something you could create by hand, but are kind of messy and difficult. I'm going to show you an easier way to do that with the look at rotation. So what we're going to go ahead and do in our C++ classes, I went ahead and already created our, it's called the C projectile. That's actually going to be our missile class here, this actual system here. So I went ahead and filled out some basic variables and stuff. So we're actually going to close the editor because I made some pretty big overhaul changes because I'm basically using this to create the class. I had one that was already there that I didn't need it. So we'll close that. That way it doesn't crash the editor or cause any wonkiness or weirdness with live editing. So in here, this is the header file. So this is just a very simple, well laid out. Basically, I went in and included everything that I needed for all of the different functions and components we're using. Make sure that if you're trying to follow this exactly, that you get every single one of these. I believe needs to be in here. There might be one or two that I was fiddling with testing some things, but it's a safe bet to go ahead and add all these while you're working on this. You can always later on, remove some and test it and see which ones aren't necessary. I think the only one that might not be necessary is this one. I don't remember. Yeah, because I think the rest are all necessary. I could be wrong on this one, though. There might be something I'm referencing. Either way, so when you first create it, you're going to get a class. Basically, it's just going to have like this, and that's basically it. So I went ahead and added all the variables we'll need. So for those who don't know, uProperty and uFunction are how you create variables and functions in this that can then be seen in Unreal Engine. So for example, this uProperty edit anywhere, blueprint read writable, and category missile means that when this gets loaded up in the engine, it is editable anywhere. So I can edit the script from anything. And it's blueprint read writable, which means I can actually edit either a direct child blueprint created from that C++ class derived from it. Or if I'm using a different blueprint, I could access the variables that way as well. So passing in getters and setters and stuff like that. And then I've also categorized it by missile. Now you can have multiple categories for this. You could have, one for missile that maybe covers the mesh stuff, and you can have one for the Niagara stuff. It just is up to you how you want to categorize it. One thing I would recommend, something that I didn't know until recently, is that there is a difference between the Niagara component and the systems. I haven't been using Unreal Engine C++ until relatively recently, but I've kind of dived deep into it. So basically, the components are great for things that you want to actually add to the actor. So things you want to be permanently attached. I don't think they necessarily have to be, but things that, like, for example, in this, I've got a rocket plume. So the whole time the missile's firing, that rocket plume's either going to be on or off, but the whole time I want it attached to the same place. I'm not like spawning new ones or anything like that. So it's a component. That way I can reference it directly in the blueprint, in the structure, in the file structure. And then the system is great because I can fire off one-offs of this. And in my final version of this, I actually have another, or well, I say final, but I'm still making edits to it. But the current final version, I've got another system that I can fire off engine plumes in different directions. So that way, when the missile's maneuvering, it can fire off plumes to look really cool. So for one-off firings, you want to have this system. Then I've got some more variables here. I've got the float for speed, which this one you don't actually directly edit. I just like to be able to see it. I probably should move it to private because you don't ever directly edit this. Speed is calculated based on your acceleration rate, your current speed, and all that kind of stuff. And then down here you got your acceleration rate, which this one I have a default value, but you can set it in the blueprint. Same with interp speed. And then here, this is the actual target that the missile is going to head to. So it's an actor, target actor. This one, when you're spawning it through a different blueprint, you want to make sure you set this to whatever it's heading towards, or else it'll just sit in place. Or if you're wanting to spawn it, like, bring it into the beginning of the level or whatever at the beginning, you just make sure that's set, or else it's not going to actually do anything. We've got, so this is a collision channel. This just bypasses, essentially I use this to bypass if you've got detection channels. So for example, I've got ships that use a channel specifically just for tracking missiles. So basically what happens is the missile hits that detection overlap and it sends a message to the target, or well, whatever actor has this detection overlap. It says, hey, I exist. Here is my IFF, mark me if you need to. And this makes it so that the AI's overlap or the player's overlap doesn't constantly be sitting there overlapping with everything. It only overlaps and reads on its end what gets sent to it. So it's messages sent to it. It's a little more performant that way. It's not like a super huge deal, but everywhere I can eke out a little bit, I can. Now this is a float for launch time. This basically just gives us, how long does the missile take to go in the upward position? Well, depending on its orientation, but it goes up compared to itself for this amount of time. I defaulted it to 1, but then we have a debugging. So this allows you to put a bunch of debugging things in throughout the blueprint, throughout the script, and then just on a specific actor, you can set that to true if you want to see what all debugging things you have printing out to the log. And I'll show you an example of how I do that in the actual main CVP file. Down here, these are the overlap. So these are really important. These are basically an array of classes. These are what you actually compare the overlap to. You could do it in a bunch of different ways. I chose to do it this way because I want to make sure that my missiles collide with, AI ships, with projectiles, but I don't necessarily need them to collide with things like the detection variables, or if I have any test dummies, things I don't need them to collide with, I don't care about comparing against. And then we have here, and then as you can see here, as we're getting to the hue functions, these are a little bit different. So see how this one's edit anywhere, but it doesn't have blueprint read writable. That is, I believe, because I don't want I don't care about adding extra classes to the missiles during the blueprint runtime. If you want to do that, you can definitely do that. For me, it's just like once I add it in a default class, that's fine. Down here, we have blueprint callable launch. So this basically just is launch function. Right now, it doesn't really do much. So you don't have to add this if you don't want to, but it's just basically things you want to do during launch. You can spawn particle effects and things like that if you want to. And then right here, this is the big one, set target. This allows you to set the target from a function. So if I want to update the target of this missile, let's say the target is destroyed, you want to update the target, you could be tracking all your currently active missiles and send them all a new target once the previous target was destroyed. That's something you can do, or they can even request one if you want to like use messaging, interface components and stuff like that. We've got on overlap begin. So this is actually our overlap function. So the way overlaps work is you create a function that you want. you request certain information, and I believe this is all the stuff that's required. I'm not sure. Believe you don't have to have everything, like you don't need the other body index, but it's better to have most of it anyways. We got a crash function, so that's just destroying the missile when it collides. And then a rotation calculation. This actually is what rotates the missile towards its target. Let me show you how we do that here in a little bit. There's some interesting stuff. I'm going to do a video in the future about how I use AI to try and see if it could write a rotation calculation for me, and it could not. It tried, and it got really close to recreating the look at target function, but it just couldn't figure out how to get it exactly right. And it did it in a much longer, more verbose way than just a simple look at target function. And this right here is a function that just checks launch time. So this basically goes, how long has it been since I launched? And I did move tick to protected. This just clears up some minor errors that they're not actually going to stop you from using it. They just live little red squigglies in your CPP file that I hate, so I moved it to protect. And then private, we got a couple. These are just some functions, variables that are things that you don't really need on the front end. So start location, current location, acceleration, timer handle, time since launch, and if you're an owner. These are things that they never need to really see on the front end. There's some other things over here, like you probably could move down there, but it's up to you. All right, so this is the basic layout for the CPP file. I've included the Kismet library up here. This is for that look at rotation that I was talking about that I'm going to show you here in a little bit. So give me 1 second here, and I will start loading in a couple of these, and we'll kind of talk about it. All right, so I've gone ahead and added the construction script, the check launch time script, the begin play script, and then the actual tick function. So let's go through these real quick. So right now, here. So with this, basically this constructor script basically runs before basically anything else happens. Constructors basically run in editor. They basically update, I believe, every time the actor is moved or placed in the world or anything like that. So basically, these are the kind of things. So for example, the create default sub-object, that is what actually creates the sort of in the actual blueprint itself. It creates the actual component items. So you get your mesh, so that's going to create the root component, which is actually what gets set down here. And then it also creates the collision box as well as sets the box extent. So when we go in editor, you'll see that the box extent is going to be 50, which is not completely correct. We'll make some tweaks to it once we're in there, but I don't have the numbers in front of me, so it's easier just to put those. Then we have our engine plume system. So this is actually our Niagara component, and we set up the attachment of these two to the actual root component, which is that mesh. And we also turned on the physics for the mesh and disabled gravity since it's a space-based game. If you're doing a non-space-based game, you could actually have it enabled that we can kind of have an arc to the missiles. Of course, that's depending on how you set them up. And then as well, we come down here, we got a check launch time. So basically this is a timer that is run. So essentially what happens is every 0.1 seconds here, this timer is adding a half second to our time since launch. The reason why, or not half second, half of a second, right? No, it's even smaller. So this is a tenth of a second, so it's half of a tenth of a second. Because the reason why I did this is I wanted to handle the time a little bit differently when it comes to launching these missiles. In theory, you could just put this to 0.1 so it matches there, so it's actually the time since launch. I'm doing a little bit of weird trickery with the lifetime of the missile. Future, it's not going to be a part of this, but that's something I want to do. And then down here, we have if time since launch is greater than or equal to the launch time, then we're going to actually clear out this timer. So basically, if this time has reached greater than or equal to our max time here, which we set to 0 on begin play, but then we reset basically every time we add here, it goes up by increment because of this timer. And then this launch time is that static variable, or not static, but the variable we set back here to 1. But basically, once it reaches that, then basically the missile comes to a complete stop. So it rises up, you know, like it's coming out of the launch tube, then it comes to a stop. And what I'm doing in my final missile version is that I play a little particle system that comes out the front to stop it, make it all fancy looking. But then we're going to get the World Time Manager. So basically, this Get World Time Manager handles all your timers. So if you're adding or clearing timers, as you can see here, we set timer down here with all its variables. Down here we're clearing it. It's all done through the World Time Manager. And then once we have cleared that timer, we then set the missile as clear of the owner. And then this is the begin play. So this all happens before that check launch timer, because that is a timer that gets set here. So we begin play. We activate the engines, basically making them light up with those 9 guard particles. We set our start location, and then we get our collision box, and we add a dynamic. So what this does is that function that we created earlier, the on overlap begin here, created right here. Basically, this calls that function anytime the engine detects that this collision box has begun overlapping something. Because the engine has its own on-component begin overlap, but it doesn't actually run anything in the actor. You actually have to say, hey, this is my function I want to run when things begin overlap. We set our time since launch to 0, clear of owner to false, and then that's when we set that timer. In the timer, you have to have a timer handle, which is the actual, like, basically the function that gets stored here, F timer handle. Probably could have put a better name for the timer handle, but then we have to reference this actual actor, and then we have to get a reference to the actual function that we're wanting to run as the timer. And we're not getting a reference, sorry, we're getting basically the address of the actual function itself. And then every 0.1 seconds is how often we want it to fire, and we want to loop. Now, if you didn't want to loop, you could put it to false, but we want to loop. And then we call launch missile, which just calls the launch missile function, which currently there's not actually anything going on in the launch missile. So, and then down here we have our tick. So our tick takes our acceleration and adds delta time, and it adds delta time times acceleration rate. So basically what happens is it takes the current time times our acceleration rate and keeps adding it up over and over and over. And then our acceleration gets multiplied by delta time again, and that gets added to our speed. So our speed builds up more and more and more. And then that speed is what actually gets multiplied by our impulse. So we're getting current location, active location, and then in here, if we're not clearly owner, we just take our mesh, add an impulse. So this basically makes a physics impulse on the actual mesh itself. And we just call to this current actor, get actor forward vector. So this is the X direction. If you're looking at your model, your static mesh, it's the X direction. And then, you get your up, which is Z direction, the right, which is the Y direction. And of course, you times them by -1 to get the inverse of all those. But we multiply that by speed to get the actual, this is basically adding the actual speed to the missile. And then down here, this is basically the last thing we do in tick. We check if the target is set. If the target is not null, or it's a pointer, so not null pointer, and we are clear of the owner, then we start doing our rotation calculations, which is what I'm going to update here real quick. I set aside the code, it's a little bit faster. It takes quite a while to code a lot of this stuff up. So rather than making you watch me do all that, I just set it all up here ready to go. So for the rotation calculation, basically it looks like a lot of programming, but essentially it boils down to we're getting the actor's location, getting the target actor's location, And then using those two locations, we're finding the look at rotation using that library I mentioned earlier. So you do have to have that library added. It basically uses the find look at rotation, and it creates a variable called rotation here. And then we also get our current rotation. So that is quite a bit. But then all of that then goes into this if else loop right here. So we basically got it's if else statement. So basically what happens is it comes in and it says if this current rotation, just active rotation, equals what we're wanting to look at's rotation with a tolerance of 10. Basically, the smaller this is, the more precise the missile will be, but the longer it will take to get to there because there's an ease in or ease out function with the interp we're using, which is rinterp2. It's not a huge thing, especially if you set a slightly higher value for your interpolate speed, which is this right here. But it can make a difference. So this, you'll want to tweak this. I'd probably create a variable and tweak this quite a bit rather than recompiling every time you want to test it. But having this be like a tolerance variable would probably be a good idea. And then in here, so if we're within the bracket of the window we want to be with this missile, so we're looking at our target, then what it's actually going to do is it's just going to straight up set the rotation of the actual actor to the target actor look at rotation. So instead of like interping to it and taking its time, it's just snapping to it. That's why you probably want a little bit smaller than 10, because 10 it'll be noticeable. At 10, at least close up, you're going to see that missile snap onto the target. But let's say once you've got it there, then you're also going to add the impulse. So this means that the missile will start firing forward along that forward vector. So that X vector we're talking about, it's going to start firing forward. Then what we will look at here in the else is basically if that's not true. So if your missile's not looking at the target, we're basically going to slowly start to rotate towards it. We create the rinterp speed. This technically is not currently being used in this. That is because this is something I want to play around with later to kind of create my own sort of ease functions and allow me to kind of fiddle with how the missiles react. But you can always bypass that and just directly, not even add this. It'll still work just the same. Down here, we create a new rotation as an F rotator. And what this does, this math function, uses rinterp2. Basically, with rinterp2, you got two options. For interping, you got two options. You got a lerp and an rinterp2. I think there's a couple other ones, but these are the two big ones. rinterp2 is the one you want to use if you're using rotational things because it's built for rotators. It actually takes in the rotators more correctly and it's going to be more accurate for rotators. But as you see, you pass in the actor's current rotation and the rotation of the look at rotation. That's basically where you're wanting to target to. Then you pass in your world delta seconds and your rotation speed. And what it does is if you've got, like, say your missile's facing this way and your target look at is here, what it does is it calculates the next step. So it goes in the next however many tick or whatever, and using that and the rotation speed, how far am I gonna move? And so what it does is it doesn't snap to it like the set actor rotation does. Instead, it calculates its next step, and then it just sets that next step. It sets new rotation to that next step, and then of course set actor rotation sets that. So it just steps through that. It makes it a little bit more smooth, especially with tick rates. It's going to be smaller jumps, so basically lower speed. So it's not moving as far. You're going to see a lot smoother of a movement. Even at high ones, it's not going to be necessarily jaggy, but it's going to like teleport basically. So you kind of want to balance, how fast do I want this to move? How much is realistic? For things that are instantaneous, like snap second, things like, let's say you're firing a projectile and for some reason it's a homing projectile. You're probably not going to care about having any kind of rinterp. You're probably just going to set the rotation and be good to go. But anything that you're going to visually see for longer than a couple seconds, you want to rinterp because it makes it much smoother. Let's move on. We've got our debugging here. These are different values that, if I've got that debugging set to true, these will print to the log. And basically, if you've never used these before, basically you just have a variable argument here. So depending on what you're returning, you want to have either like %s, %f. And those are just kind of like %f is for float. You got %s for string. And then in here, you got your log temp. This is the actual log itself. You can use the logs that save to the actual file. There's like a text log file save. There's a log temp, which is the one you actually see in the editor. I think there's another one that prints it to the screen, but I'm not entirely sure on that. I'm still learning about UElog. Then you've got this. There are a couple different warnings. So you've got the warning, you've got log. I'm not sure. I think there's one other one that's like error, and basically it highlights them in a different way. So log is going to be plain white. So if you don't care about it, you just want to make sure it's logged somewhere so you can look at it later. That's the one you want to use. Warning, which is yellow, which stands out a little bit more, so you can see something. Something's crawling across, you can see it more quickly. You got red, which stands out very quickly, and you can filter by any of these. When you're in the actual log, I'll show you later. You can filter by any of those. But yeah, so that is our rotation calculation. So we're almost done here. We've just got a couple more left. So we got our crash system, which is super simple. Basically, this does two things. First, it it spawns a Niagara system at the location where the missile has a socket. So basically, I came in here and I basically get the world. This basically gets the actual level you're in. And then it uses that Niagara system to spawn. And then it takes your current mesh and gets its socket location. You get to provide it a socket name. So that gets the exact location of that socket. And you get the active rotation. This isn't super important for explosion, but for some things it could be important. And then you set an F vector. So this is a scaling. So you can leave it, I believe you can leave it blank and it scales it to 1. This time I've scaled it up to 5. I think actually make that 10. Make it 10 times as big of an explosion. But yeah, so then you've got that there. And then after that, I destroy it. So when this crashes, it spawns an explosion and destroys the actor. By doing it spawn system application, you're actually destroying the actor, but not the Niagara particle system. So the particle system still goes through all its steps without being destroyed when the actor gets destroyed. Because if you didn't do this, you just have the system, you activated it on the actor and then destroyed, you would end up with a system just getting cut off halfway through. All right, so I think the only one we have. Okay, yes. So there's 2 left. This very simple one, set target. All it does is just go this target actor equals target. Super simple. Should be pretty obvious to anyone who's done any coding before. And then we've got this. So this is our on overlap again. Also relatively simple. So yeah, all it's really doing here is we're basically doing a very simple check here at the beginning. If other component and other actor exists, and other actor does not equal this actor, so make sure you're not checking yourself for overlaps. Then we just come in here, get the actual component of whatever we overlapped. This is something I'm doing where I'm just checking the overlap channel. If so, you can just ignore this part and just put this for loop in here. And what you'd want to do is you're just checking these class variables. So basically, for class in class variable, basically it'll loop over all of the individual classes here. What it does is it actually checks if you're overlapping with that component. If the other actor is of, when you get their class, is of this class type, crash. That's it. So let's go ahead and save everything here. Should be just, let's go ahead and start up the editor. Make sure that it's compiled properly. So I just do this because sometimes this will catch things that the actual Unreal Engine build tool didn't catch. But yeah, fine. So let's take a look. So what you'll do, normally you'll come in here. If you don't have a blueprint class, you'll just right click, create blueprint class based on, and then you'll select where you want it. So here, C projectile. So, and so this is what's known as the data blueprint. So it's got all the information we need here. So let's go ahead and just open up the full blueprint editor. And as you can see, everything looks great. Sometimes it's not always set up in the orientation you want, so you'll just make sure to check everything. Bloom, your collision boxy. So the box extent is actually 350. That's what I said. This. That way it's more accurate to the missile size. Then I've selected my engine bloom. You'll be able to select whatever you want here. And also I rotated it and moved it to the place where it needs to be. Go to our class defaults. This is those defaults I was talking about. So, yeah, the speed, you don't even touch that because it's going to get updated. We've got our acceleration rate. We've got our interp speed, which I've just set to 1. Target actor, that's the one we need to set in the actual level or when you're spawning. Section channel, y'all can ignore. Launch time, 1 second. False, and then class variable ship high. So we come over here to the actual ship that I brought into the level. See that it's pretty much identical, except I tweaked some things. So I lowered the interp speed to make it a little, yes, we're showing it off here. 2 seconds, so it takes a little off. Let me actually hit yes on debugging so I can actually show you what that debugging log looks like. So come over here, this is our temp log. So we're looking at our output log, that's what we're going to look at. Let's go ahead and hit play. You can see here it starts flying up, and boom, see how the rotations are showing in the log, and it's properly. And once it's locked on, poof. Now you saw that little snap. That's what I was talking about when I was talking about the tolerances. If you lower that tolerance, it's going to take just a little bit longer to pitch over, but it's going to be less visible to the player, and you can always raise the interpolation speed to kind of fix that. Yeah, you saw it collided with that ship, exploded, and there you're good to go. So that should be just about everything covering this. If you have any questions, make sure to leave them in the comments below. Otherwise, good luck. Good hunting.